Well, thanks so much for having us. We're going to get right into this because we have limited time and a lot to cover. So as you said, we're going to do 8 best practices for writing secure Go code. And as a quick introduction, Eric Smalling, I'm a developer advocate here at Snyk. I specialize in container and cloud native, and I'll let Dan introduce himself.
Hi, everyone. I'm Dan Enman. I'm a senior software engineer here at Snyk, and I work on mainly our reporting system.
Awesome. Well, let's get right into it, Dan.
Cool. Yeah. So the first thing we want to talk about today is Go modules. If you've written Go code recently, you're probably familiar with Go modules. It's native Go tooling built into the Go tool, and it replaces a whole bunch of other dependency management tools that were used before. It has a lot of really nice features. You can do replacements on dependencies if you need to, and you can easily manage and upgrade your versions with the Go tooling. So I'm going to show a quick demo here. And we have a module called GoMod, and in it, there's a super simple main file that has an import for github.com/package errors. Let me check out the Go mod, and I can see that it's included there with the version number, but I know that there's a version update available for 0.9.1. So I'm going to run the update with go git, and it's going to go and get the package and update it. And now I can check in my go.mod file. And in my go.mod file, I see that it's been updated. The version has changed from 0.9.0 to 0.9.1. And everything's great. And if I check my Go sum file, I can see that there's a checksum in there for that version as well. So that's really cool. Go modules are awesome. You know, they have wide support throughout the ecosystem, and a whole lot of the community supports it. So if you're not using them already, highly recommended. The next thing to talk about is use of reflections. Reflections they can be very powerful, but they can also be very dangerous. They can cause all kinds of subtle runtime errors that you can't check with the type checker, can't catch at compile time. They can make it really hard to reason about the code that you're writing and talking about, because they use internal types to reference certain types and values in Golang. You know, if you can avoid reflections, I would highly recommend you do it. You know, if you can generate types with Go generate, or if you can kind of work things in a different way. If you can't avoid reflections, it's a little unfortunate. Make sure your code is, you know, well written, well documented, understandable. Write some tests, and definitely cross a finger or two just in case. Let me give you some quick examples on what Go reflections look like. So here's a quick function that takes called reflect that takes an interface, and I'll just show you what the types that the reflection system is dealing with. So here we're passing it a string, and here we're passing it a pointer to a struct with a string slice inside. And when we run this, we can see that that the types that we're getting back are a little bit confusing. So we see here we have the value given back, and the value in the first case is, you know, hello world, the string we gave it. In the second case, it's the struct. The interesting part is the reflect type down below. So that's the type that we do when we do a type reflection on it. That's the type that we get back. You'll notice that it does not look friendly at all. It has all kinds of internal pointers and information to things that are going on in the Go runtime. And it's not really super fun to deal with. You can see that if we stringify it, though, we can get the value of what the name of the actual thing held is. Let's take a quick look at another example. So here's one where we're casting an integer. So we have a function called reflexInt. It takes an interface and reflects the value to an integer. And we have two cases here, an integer case and a float case. And in both cases, we want to pass an int back. So let's see what happens when we run it. And when we run it, we can see here again, the first one, we passed it a 42, we got a 42 back. The second one, we passed it a 4.2, so that's a float. And Golang is panicking and saying, what you give me is not what I need. So I'm gonna just stop trying now and give up. And that's what it does. And then finally, we have one last case. This is similar to the last case, but it's using an interface. So here we have an interface definition. The interface definition has two services that are defined for it, A service and B service. Up here, we're creating a B service and we're passing reflect service. And in reflect service, we take an interface, the interface service. Here, we want to return a pointer to A service. And there's some information so we can see when we run it what happens. So let's get out of here in a second and run this. And let's see what happens when we do. So as expected, probably, we have some information here. Again, this is the internal type that the reflection system is giving us with all kinds of scary looking values and pointers and things like that. And then here we can see that the interface conversion failed because if we look back here, what we're doing is we're reflecting it and we're expecting a pointer to an A service. This can happen, in this case, or in other cases, if you're doing dependency injection with reflections, if you have a pointer and you have a bunch of things that or a certain interface, you have a bunch of things that match that interface, you could cause problems because reflections will pick one and then you might be dealing with the wrong type. This tip is great for any language. The nice thing about Go is Go makes it really easy. And I think the real tip here is use the standard library, get to know the standard library. It has all kinds of really great things included in it, from HTML templating to plain text and SQL. And really, you shouldn't be trusting your user input. You can validate it. You can use the templating to clean it up. But get to know the standard library and always validate your input.
That's awesome. Let me talk real quick about vulnerability scanning. So as we all know that, what we ship isn't really made up of, the majority of it isn't made up of our code. It's a lot of libraries and modules like we were just talking about. And hackers know this as well. And unless a hacker is extremely intent on your exact situation, they're not targeting the code you've written. They're targeting vulnerabilities and exploits in code that are in these standard modules. And it's a moving target. So unless you're really watching all of the release notes and CVEs that are found in every module you're using and every transitive module that they depend on, you're not going to find everything. So tools really are essential in this area. Now, a lot of these tools that have come out over the years, depending on what kind of a platform you're on, end up usually being at the far right-hand side of a pipeline, after functional testing or something, because they're heavyweight. They take a long time to run. They might have heavy licensing schemes, things like that. So you want to look for a tool that you can push towards the left side of that pipeline, the whole shift left stuff you always hear about in the security realm. And in order to do that, the reason you want to do that is because you want fast feedback. Just like CI changed the world with getting your tests running every time you commit and making sure you found out about a failure right away. But you want to find out about security failures right away. Now I'm going to show our tool. I'm not here to pitch our tool at all. Just know that there are tools out there that do this, and make sure you're getting one that helps enable your developers to be proactive. So here we have an example of a command line version of the tool. So we're just running Snyk tests against our Go modules. It's going to analyze them. It's going to query the backend database. And then it's going to spit out a bunch of vulnerabilities, as well as the versions, if there are any, where these vulnerabilities are remediated. So you can go in and say, oh, I need to upgrade this version of that. Let's go ahead and jump to the next slide. Another great way to get your developers to be proactive is to move it into the IDE. There we go. As we get the slide going. And here's like Golang. A lot of us use Golang as our IDE, and you can have a plugin that's doing scanning right there. You can get a nice pretty version of the same kind of vulnerability output with a little more information maybe that's available right at your fingertips. You can say, hey, like in this case, the font's terrible there, but if you upgrade to this version, you're going to remediate this problem and maybe others that are in the list. Let's go ahead and skip to the next. Yeah, so make sure you're getting scanning in and getting it as close to the developers as possible.
Cool. So the next thing I want to talk about and run through some demos of is unsafe in particular. Cgo is mentioned on here. Cgo is not terrible, but Cgo is not Go. And it can add some complications, build and performance complications. And really, if you're writing Go and interacting with a lot of Go code, there should be a native Go library available. So that's the recommendation. Talking about unsafe, on the other hand, unsafe can be very dangerous. It helps defeat the type system. It helps kind of render it a bit null and void, because it lets you read and write arbitrary memory values. And you can do all kinds of weird things in here. And I'll show you some examples of some weird things that you can do, and also some ways that you can cause problems for yourself later on down the line. Cool. So the first one we have here is just showing what some constants that the unsafe library package will give you. And these are constants. So if you have a float 32 and you pass it in, you'll get these same values back. So let's run this, and we can see what we get for the alignment and size of values here. And we can see that this is a unsafe pointer to float 32, and these are the values that we've given it. So that's interesting. I mean, that's some information. It's not going to cause you any trouble when you go and run. And let's take a look at this one now. So we know we can take pointers, unsafe pointers, and we know we can do things with them, and they have a size and alignment. But what happens if we try to take an unsafe pointer from one type and kind of convert it into another type? Well, we have this example here that shows exactly that. We have three functions here: pointer conversion, which takes an int32 and returns an int16. The 64-bit, which takes an int64 and returns a unsigned integer 16. And finally, the last one, which is probably the most interesting case, takes a float 64 and returns an unsigned integer 16. So there's all kinds of things that can go wrong here. And let's see what happens when we run this. So when we run it, we get some values back for the conversion. So we have the conversion from int32 to int16, 42. The conversion from int64 to int16, 42. The conversion from float 64 to int16 gave us something else that's not the right number. So here's a way in which you can cause some trouble if you're reading and writing arbitrary memory, and the alignments don't line up and things are wrong. You're going to get data that's not the data that you're looking for. All right, so let's talk about something interesting again quickly and unsafe. So we can do some pointer math here. So we have a slice of strings. It says hello and unsafe. We have down here a really ugly looking expression that casts some pointers and does some things. Essentially what it's doing is taking the pointer to the first element and then offsetting some memory to the pointer, well, in this case, the 0th element, which is the first element. And in the second case, taking the pointer to the first element and offsetting it for the size of the first element. So let's see what happens. It's probably pretty predictable what we're going to see in the end. And when we run it, we get what we expect. We get the two values back, hello and unsafe, from the slice. There is a way that you can cause some problems with the pointer math in this way. So here we have a string slice again. It has length 0 in this case. Went too fast. Has length 0 in this case. So what happens when we take the pointer to the first element and then try to get that first element? And let's run it. And when we run, we can see that, well, it panics, and it panics because we're trying to get a value out of the slice range. And lastly, this one is interesting because it combines some of the reflection stuff we talked about earlier with unsafe. Here we have a string, hello unsafe, and we want to create our own string header from it. So we have the data and we have the length. We know those things since we have the string here. So we're taking an unsafe pointer to that string, and we're setting it the length of the header to the length of the string, and then we're casting it back into a string. Let's see what happens when we do that. When we run it, we will see that we get kind of weird data back that does not look right at all. It's just kind of random garbage that Go gave us for that string. It's definitely not the string hello unsafe. And we definitely lost that value when we converted over. So there's definitely, it's definitely possible to lose data, corrupt data, convert data into formats that it just doesn't convert into safely. So be careful with unsafe because it's not safe. Cool, and this tip is very similar to the previous one, talking about dependency injections. And really, again, use the standard library. The standard library has all kinds of really great packages inside of it, including a crypto package. The crypto package has great support for all kinds of hashing and encryption algorithms, has great support for PKI, has support for net HTTP, which is great because that's what a lot of the popular libraries and frameworks for the web are built on top of these days. So again, check out the standard library, get to know it really well because it has all kinds of really neat things inside there.
And back to me. So our surveys are showing that about 60 to 75% of the production deployments now are going out in containers, depending if you include serverless or not. And that means a lot of you that are watching this are also shipping in containers as well. And one of the things that's new for development or for developers when you're dealing with containers that you haven't maybe had to deal with before is the operating system packages, the file permissions, user IDs, all that kind of stuff that might have been handled by your operations or your sysadmins, your security departments, your middleware tier people before. Now that's being added to your plate because now you're in charge of Docker files or Kubernetes manifests or whatever it is you're using for your infrastructure as code, your Terraform scripts, everything like that. And what you don't want to do when it comes to your containers is make an image for that container that contains a bunch of tools that are going to help a hacker out should they find an exploit and get access to, through a remote code execution vulnerability or something. In order to do this well, you really need to understand how image layers work, and especially with the base layer. So when you build your image, you've got all these layers that make up the file system, and you have a starting point, and that was what we call the base image. There are all sorts of different base images out there on the official ones out on Docker Hub. There's ones from your vendors. There's ones that your own business may be producing. They can start from places like Ubuntu or CentOS, or even if you might be looking at some of the Google distroless images. Those are good choices because the distroless choice, that's a very pared down and minimized image that doesn't contain much else than what it takes just to run your application. So there is a Go version of that. There's also Java and other ones. That might be a little too much because it's so stripped down. There might be some diagnostics you need to be able to do that aren't in there. You might also take a look at Debian has slim images, which are not quite as drastic as distroless, but they are slimmed down and much smaller. Alpine is another interesting one to look at. Alpine started before containers became popular as a small footprint OS that has a kind of a nod to security because of the small footprint. It does use it doesn't use glibc, it uses muscle C, so you can make sure that works for your application. When you're looking into this, though, the technology you really want to get your hands around if you're using Docker build to build your images is the multi-stage Docker file. Let's go ahead and jump to the next slide, Dan. So here we have get it going here. Here we have a Docker file that is showing us a simple Go application. It's got a whole bunch of lines here that are setting up all those layers. It's setting some environmental variables. It's building the app, setting a user up, and then running the app. And if you look at the bottom of this screen, you'll see that this image, if you were to build it, is over 1 gigabyte in size, which is huge. There's a ton of stuff in here that really doesn't need to be going out to production. You don't need a full Linux file system. This is a tool called Dive that allows you to dive into images. It's an open source free tool out there. And you can see on the left all the layers. You can see the sizes. We start with 114 megs, 16, 18, 146, and so on. That all adds up. And you've got all that Linux file system. You've got all of that, the Go. You've got your own source code actually in this image. That's not what you want shipping to production. So here's how multi-stage can help you clean that up. So come on, video. There we go. In the multi-stage build, you have multiple from lines. In this case, we have 2 stages. The top one at line 1 and the line 14 for the second one. That last stage is the only one that actually builds the final image that goes out. This stage you can see is using scratch, which is kind of a Dockerfile keyword for nothing. There's nothing in this file system. There's no base image really. All that's happening in here is we're copying a couple things from the build stage, which you can see at the top, you see as build on that. So it's copying the my app and the password in this case, which contains the user we just created, and then setting it up to run. So if you were to build this and take a look at the sizes of it, I'm overextending my recording. There we go. 11 megabyte roughly. That's drastically different. And if you use that dive tool to jump in and see what's in here, you can obviously see. Let's jump out of here and go into that image. It's 2 layers: the app and the password file, and nothing else. So if a hacker was good enough to break through some vulnerability in your app, he has no toys to play with inside this container. There's nothing in the file system to help him or her set up a beachhead to start hacking around. Go ahead and jump to the next slide, Dan. So that brings me to scanning. So just like we talked about scanning for your modules and your code vulnerabilities, you also, if you're using any kind of image, base image that is more than just scratch, you want to scan for vulnerabilities in the operating system, the packages that are in it, and things like that. And we have a tool that does that, but there are many tools for scanning that. Make sure your registry or your CI tool or even your command line, that you have a tool that you can monitor that, especially as vulnerabilities are found. You want to be able to find those vulnerabilities even if you haven't changed your Docker file. And lastly, outside of the containers themselves, when you get to runtime, there's other things you can be doing that can help you, provide security in depth, such as, can you run your container with a read-only file system? This is huge. Immutability is awesome, because then if a bad actor does get in, they can't modify the file system. They can't curl in their own scripts. They can't modify your executable. They can't clean up after themselves by deleting logs. Also, don't run as root in your container. The UID 0 means things, and if they were able to break out of that container, or if there was anything volume mounted in, that UID 0 would be able to read and possibly write to files that were, if that was a bind mount on your host system. That's horrible. Privilege mode, don't use it. You probably don't need it. 99% of people don't need that. If you want to know more, search on why. Linux capabilities are awesome. The Docker team years ago figured out a pretty good minimal set of capabilities for most containers, but actually most applications don't even need what that gives. So then drop all your Linux capabilities and only add back the individual ones you need, like catnet add or something like that, or catnet raw, sorry. Cgroup limits. So limit the CPU and RAM you give to a process in a container. That way, if there's something wrong with the process, or if a bad actor were to get in there and start to try to crypto mine in your container, it will be limited to a finite amount of RAM and CPU and not everything that the cluster node gives it. And finally, if you're on Kubernetes, network policies are your friend. They allow you to limit traffic, TCP or UDP, and to specific ports between the pods and in and out of namespaces and things. I am a fan of zero trust network policy, meaning no traffic is allowed at all, and only what I then additively allow gets allowed. So I say, this kind of pod that matches this selector can talk to this kind of pod on TCP port 8000 or something like that. And only that traffic is allowed between the pods. So that is that. And I think I don't know if we have time for Q&A, but we'll be happy to hang out for that. Dan, you can go to, I think that's our last slide, right? I think it is. So thanks for listening. I cannot hear you.
Yeah, Taylor, you muted.
Oh, there we go. Sorry.
There we go.
Yeah. Trick of the stream. Thank you both so much. That was really fascinating. I couldn't keep up with all of my notes, but tried to make some shorthand on things I definitely need to take a look at and learn a little bit more on. I think that we did have time for just one question. And that one question is, Snyk is a really wonderful and powerful tool to be able to keep up to date with a lot of things happening in the world and with your code stacks. Aside from using Snyk, are there any good sources that you can point people towards to keep up to date on things? I know, with security, it's ever changing. So same with just about everything in technology, but are there any good sources that y'all can point out or kind of to let us know about that might be something good to, keep note of?
From the container and Kubernetes side of the house, I can tell you Get involved in the SIG communities. Get involved in the in SIG on the Kubernetes side, TAG on the CNCF side. But if you're really into networking, there's a networking SIG. If you're really if you want to know security, SIG security, I'm in there, and we have a whole tooling sub group that we do things from. That's my number one thing. And then just follow the experts that you see in there on Twitter. That's the way I keep I get the freshest info around that kind of stuff.
Awesome.
Dan, do you have any
thoughts?
recommendations for Go?
The Go community is pretty good. The Go issue tracker is great. There's lots of great stuff on there. If you're just getting into Go, the Go homepage has a playground. It has resources that will guide you through all kinds of things in the playground to learn it. If you know Go or if you're learning it, effective Go is always a great read again and again with all kinds of great insight in there. And keeping up, Twitter, follow lots of Go developers on Twitter. I'm sure they'll keep you up to date as well.
Awesome. Well, thank you so much for all of the insight on writing secure Go code. I think next we'll be bringing Wilkin to the stream to talk about Packer.